Hello, everyone. Welcome back to the Math Magician's Den. We're going to talk about some limits today, and everything we're going to do today involves trigonometry. If you watch some of my other videos, you've seen, maybe you've even seen in your classes, these basic trig limits. The first one up here, the limit of as x approaches 0 of sine of x over x, that limit equals 1. 1 minus cosine of x over x as x approaches 0, that equals 0. And the limit as x approaches 0 of tangent of x over x, well, that's also 1. Now, what do we do if we're looking at this limit, but it's got some numbers involved, like sine of 5x over 3x? What are we going to do? Well, there's a little procedure here that I can show you that may help out. Now, what I'm going to do is I'm going to rewrite this limit as x approaches 0, and I'm going to give myself a little bit of room here. I'm going to put sine of 5x over 3x. Now, you know the property says I want sine of x over x. So maybe what I can do to get somewhere with this problem is I actually divide this top by x to make it look like the formula, somewhat like the formula. But that means I also have to divide the bottom by x. Okay? Now, the other thing I'm going to do is I'm going to take the top, and I'm going to make these two formulas right here match up. That's a 5x, so I'm going to make this a 5x. But that means I got to multiply here by 5 as well. Why? Because 5 divided by 5 is 1. Whatever you do to the top of a fraction, you have to do to the bottom of a fraction. Now, what happens here is this. We're going to take a look at this as basically two limits. We're going to take the limit as x approaches 0 of the top here, and this would be 5 times sine of 5x over 5x, and the bottom would be essentially the limit as x approaches 0, and that reduces to 3. So I already know that the bottom limit is going to be 3. The top, there is a property that you've discussed in your classes, or you've seen in one of my videos, where you can bring this constant out front. A constant times a function ends up being the constant times the limit. So I can take that 5 out front here. And I've got sine of 5x over 5x on the top here. Now, here's the thing that is very important here. If x approaches 0, doesn't it make sense that 5x also approaches 0? So right here in my limit, instead of writing x approaches 0, I'm going to write 5x approaches 0. And this limit that you guys see on the top right here is essentially the same as this. It doesn't have to be x. It could be y approaches 0, sine of y over y. It could be m approaches 0, sine of m over m. Well, this one is sine of 5x over 5x, and 5x is approaching 0. So that limit is 1. This limit is 5/3. Now, can you see a shortcut to this? If you see a problem where I've thrown in some numbers into this sine of 5x over 5x or 3x, do I have to go through all this work? No, it's just 5 over 3. So if you run into something similar to this and you see the limit as x approaches 0, and let's say it's sine of 10x over 7x, what do you think the answer is? You're right. It's going to be 10 over 7. It's that quick and easy. Could I do the same thing with tangent of x over x? You'll notice at the top of the screen, I've got this tangent of x over x right here equals 1. Well, what if I put the limit as x approached 0 of just tangent of 9x over x? What happens if I throw a 9 in there? What do you think? All the same rules, this is going to come out to be 9. Now, these next two, I am going to basically show the work on this second problem, but the third one, we're going to kind of do a shortcut. So what I'm going to do is I'm going to rewrite this limit like I did before. The limit as x approaches 0, and I'm going to put sine of 4x on the top, leave myself a little bit of room, tangent of 9x on the bottom. Now, what am I going to do first? Well, I'm going to divide the top by x, which means I got to divide the bottom by x. What else? Well, I'm going to divide by 4 here to make that a 4x, but then I got to multiply by 4. The bottom, I got to divide to 9 to make it 9x to make it match up, but then I got to multiply by 9. Now, if we take a look at everything I'm doing here, on the top, I have a 4 out front, and this is the limit, and you know how I'm going to write it. I'm not going to put x approaches 0. I'm going to put 4x approaches 0 of sine of 4x over 4x, because if x approaches 0, well, then 4x approaches 0. And on the bottom, I'm going to do essentially the same thing. I'm going to put the 9 out front. I'm going to take the limit, not as x approaches 0, because if x approaches 0, doesn't 9x approach 0? And this would be tangent of 9x over 9x. What do these limits approach? Well, that top limit right here, sine of 4x over 4x, as 4x approaches 0, would be 1. Same thing on the bottom. The limit as 9x approaches 0 of tangent of 9x over 9x would be 1. So my limit here is 4/9. Can you see the shortcut? So that last problem on the page, what is the limit of sine of 4x over 5x? Take a wild guess. I'll bet you got it right. It's 4/5. So hopefully you can see the shortcut on a problem like that. Let's take a look at a few more. We've got sine of x to the 6th over x to the 6th. Now this one's actually pretty simple to figure out. This is the limit as x approaches 0, and I see that formula, sine of x over x. But the top is raised to the 6th, the bottom is raised to the 6th, so the whole thing is raised to the 6th. If you have a function raised to a power, if you watched my videos on properties for limits, you can take that limit and raise it to the 6th power. So this would actually be 1 to the 6th power. It would be 1. That would be my final answer. Now, what if, just let's change one thing on this. The limit as x approaches 0. What if it was sine to the 7x over x to the 6th? Well, you notice what I've got there, I've got an extra sine of x. I've got sine to the 6th x over x to the 6th, but I got an extra sine of x. Well, when you multiply functions, you can multiply their limits. The limit of this first one, we already know from the previous example, is 1. And this one right here, I can plug in 0. What is sine of 0? Well, it's 0. So the limit of this one is 0. So those formulas can even help us figure them out when the powers don't match. Now, these next two are kind of tricky. I can think of several different ways to do this first problem with the secants. Now, I know I don't have any of my original formulas that involve secant. It's only cosine. So maybe I write all of this in terms of cosine. This would be the limit as x approaches 0. And on the top, this would be 1 over cosine of x minus 1. And essentially, the bottom is going to be x over cosine of x. Now, the one thing we talked about in mathematics, we don't really like fractions within fractions. So what I'm going to do is I'm going to multiply the entire top by cosine of x. I'm going to multiply the entire bottom by cosine of x. And what's that going to do for me? It is going to create a new limit. As x approaches 0, right here, the cosines would cancel, and I'd get 1. If I distribute here, I'm going to get minus cosine of x. And on the bottom, the cosine of x's are going to cancel. I'm going to get x. Well, what do you know? That's one of my original formulas. What's this limit equal to? This limit equals 0. Now, we always run into problems with this last one. This last one, it's like, okay, what am I going to do to work this problem out? Because 1 minus cosine over x is equal to 0, but I have an extra x on the bottom. And what I've had some students try in the past, and I'm going to erase this in just a minute, they try and do 1 minus cosine of x over x, times 1 over x. Well, yeah, this comes out to be 0, but you're multiplying by 1 over 0, which is 0 over 0. And ladies and gentlemen, that is an indeterminate form. So we're kind of stuck here. Now, this is a little trick. There is something with trig, hopefully someone taught you. If you see 1 minus cosine or 1 minus sine or 1 plus cosine, one of the things you can do in trig, just to change this up a little bit, we're going to multiply by its conjugate, 1 plus cosine of x. And what happens here is, we're going to change this limit a little bit, and I'm not going to multiply out the bottom. I'm going to leave this as x squared times 1 plus cosine of x, but the top comes out to be 1 minus cosine squared x. Do you recognize that from anywhere? Because I tell you what, we have a formula that says sine squared of x plus cosine squared x equals 1. We have a Pythagorean identity. So if I move this cosine over here and put 1 minus cosine squared, I can rewrite this limit. This limit is now sine squared of x over x squared times 1 plus cosine of x. Do you see it? What I've got here, right there, sine squared over cosine squared, or sine squared over x squared. That limit is 1. Now, what about the cosine? Well, think of it as a fraction, 1 over 1 plus cosine of 0. What is cosine of 0? Cosine of 0 is 1. If we work this out, the limit comes out to be 1 over 2, 1/2. Hopefully this gives you an indication of some of the things you may have to do with limits and trig. If you like this video, please hit the like button. If you like the content you've been seeing, please subscribe to my channel. I'll have more videos later on.